Question number 1. Calculate the amount of quanta of radiation of the frequency 4.67 into 10 raised to 13 per second that must be absorbed in order to melt 5 gram of ice. Given that the energy required in order to melt 1 gram of ice is 333 joules. First, we shall understand that how much amount of energy is actually required in order to melt 5 grams of ice. That would be simple as energy. The energy required would be equal to 5 into 333 joules. That would turn out to be 1665 joules of energy that has been required. Right? Now, secondly, they have asked us in order to calculate how much amount of quanta of energy that is required. So therefore, we shall use the energy associated with the quanta as, so the energy associated would be equal to, that is E is equal to N into H into nu, right? So therefore, we are looking at the number of quantas. So the number of quantas would be equal to energy by H into nu. Therefore, the amount of energy, the total amount of energy that what we have seen so far is 1665 joules, right? So therefore, we'll have it over here as 1665 joules. The whole thing would be divided by H. H is a Planck's constant. So the value of Planck constant would be as 6.626 into 10 raised to minus 34 into the frequency. Frequency is 4.67 into 10 raised to 13. Right? So therefore, when we try to calculate this value, n is equal to, so we would get a value when we solve this entire scenario would be nearby 53.8. Okay, so it will give us to 53.8 into 10 raised to 21. Okay, so that would be as, if we just shift the particular decimal point to the left side, it will come to 5.38 into 10 raised to 22 number. So therefore, our option over here is the option C.